Namaste.
In the mythos of mathematics, the inspirational story of Srinivasa Ramanujan is unparalleled. His letter to G.H. Hardy, barely a few months before his death, had hinted at the mysterious Mach theta functions. Now, over 90 years later, the last prophecy of Ramanujan is slowly revealing its tantalizing secrets, uncovering fertile realms at the very edge of the mathematical world. Q-series, harmonic mass forms, quantum modular forms, automorphic forms, and many more, leading to new and spectacular breakthroughs in the field of number theory in mathematics. The genius of Ramanujan preoccupies generations of mathematicians even to this day.
Beautiful, beautiful functions. So unlike Rogers. Mach theta functions. That's what I will call them.
"25 years ago, I made this film, probably the first dramatized documentary produced in India, to mark the centennial celebration of the great mathematician. The enigma of Srinivasa Ramanujan has endured the passage of time. Ramanujan continues to be an enigma even today. To unravel the mysteries of his mathematics is an infinite task. Yet, we are not trying to do the impossible.
We are trying to present some facets of his life and work with a fond hope that it might excite the curiosity of some young student who would then go on to understand the depth and beauty of Ramanujan's mathematics.
It's in this small town of Erode that Srinivasa Ramanujan was born.
Ramanujan? Did you say Ramanujan?
Yeah, if you look at the horoscope which was prepared when he was born, it is written as Ramanujam. But the English anglicized it to Ramanujan. The world knows him as Ramanujan, but we know him as Ramanujan.
That's right. Although he was born here in Erode, but Kumbakonam played a much bigger role in his life.
Come, let's go.
This is the house where Komlattammal, the mother of Ramanujan, was. This is the parental home of Ramanujan, and this is where he was born. Now house is named as Jyoti Nilayam, and that seems to be only in the year 1951.
So was the original house broken down and rebuilt in 1951?
No, actually somebody else bought it and rebuilt it, reconstructed it.
That's kind of sad.
The original must have been like the house at the far end of the street.
Look at this. What is this, like 200 years old?
Yeah, the last remnants of a bygone era.
Really? Hey, look at this. The house is sunk way below the road after many years of probably many resurfacings of the road.
Yeah.
Look at that.
Look at those tiles.
Taye, Amagiri, Davama, Davamirundu Chetta Korandadi, Idandi Kapatan.
ஸ்ரீ ராமானுஜர் அவதார தினமான வியாழக்கிழமை என்று பிறந்திருக்கான் குழந்தை. அதனால் ராமானுஜன்னு பெயர் வச்சுருங்கோ.
If we go back to the last letter of Ramanujan, is very clear now, and in fact, it's a shame he died too early. He starts this. I have discovered Mach theta functions. Unlike the false theta functions studied by Rogers, and we'll talk more about the Rogers-Ramanujan identities and how they relate to this, but a letter says, unlike the false theta functions studied by Rogers, they enter into mathematics as beautifully as the ordinary theta functions. So Ramanujan seems to be disappointed in the false theta functions. They're somehow unnatural. I first heard the story of Srinivasa Ramanujan when I was a teenager living in Baltimore, Maryland in the 80s. A letter came from India addressed to my father. It was a letter from Janaki Amal, Ramanujan's widow. And she was thanking my father a gift he'd made. It was a contribution to the making of a bust of Ramanujan. I didn't know who Ramanujan was, so I'd ask, who was Ramanujan?
Ken, we are on our way to Kumbakonam.
It's a journey of discovery.
In the spirit of pilgrimage, visiting places associated with Ramanujan.
You know, Ken, Ramanujan had a good sense of humor. When Tanjavur was suggested to him, he was sick. He said, Tanjavur? I don't want to go there. It reminds me of Tanshavur. He was punning on the word Tanjavur. A place where I died is what it means. I don't want to be there.
Then he can say that, the last letter that he wrote to Hardy and get on what you were saying.
This documentary is an attempt to imagine the cultural and mental landscape of Ramanujan, to bring to light his intangible presence. The depth of his creativity can only be allured to make evident his place in the history of mathematical thought.
This is the Krinan bungalow where Ramanujan stayed for a couple of months before he shifted to Gometra, where he unfortunately died along the illness.
Gometra is where he studied the Mach theta functions, right?
Yeah, by Mach.
By Mach, yeah, that's the question.
Well, the Mach theta functions, I've spent years thinking about these functions, and what you just asked is the main question. So for many of us working in number theory, the mathematics in Ramanujan's last letter, the very last letter he wrote to Hardy, has been a mystery to us. This letter was written in 1920, and until very recently, the question you just asked, why Mach, is exactly the question we would ask, except we didn't know what the Mach theta functions were. And it turns out a few years ago, there was a great thesis by a Dutch mathematician named by the name of Sander Zwegers, who finally figured out what these Mach theta functions are. It's a very technical object, but it turns out that with this understanding, we've been able to prove lots of wonderful things in math. Math physics, and probability theory. It's been incredible.
Is this business of Mach theta functions and the rest of it useful today in current day mathematics?
Oh, absolutely. I'd like to think of Ramanujan's last prophecy as a treasure trove of math. People are even using them to study black holes.
Black holes?
Black holes.
Wow.
And you see, this discovery that the Mach theta functions, the discovery that Zwegers made, is quite a historic event for mathematics. There have now been many applications in mathematical physics, combinatorics, and number theory. It's really an incredible sequence of events. I'd like to think of it as this. Our understanding, which is only the result of the last 10 years of work, is the realization of perhaps Ramanujan's last prophecy.
That's amazing.
It really is amazing.
So could Ramanujan have foreseen the mathematics that's come out of Mach theta functions today?
Oh, I don't think so. Most of the applications that I've discussed involve objects that weren't even defined until long after his death. This is all brand new stuff. But there's a related question. Many of us who work in number theory, we feel like we've been playing catch-up. Every few years we figure out a little bit more about the mystery of Ramanujan. We've learned about Dyson's rank function, and then we learned about the crank function, and now we're beginning to learn about the Mach theta functions in some real, concrete, rigorous sense. And what we've now learned, and it's 2012, this letter was written in 1920, we've learned that all of these objects are interrelated in ways that we're only beginning to understand now, despite the fact we've been working on these objects for decades. So I'd like to think of the Mach theta functions, the crank function, the rank function as beautiful instruments, musical instruments that Ramanujan gave us hints of. And now we see that they all fit together beautifully in one harmonious orchestra.
That's beautiful.
That's the result of this prophecy.
Kumbakonam was called as the Cambridge of the East. You know, you had a college, you had a high school, you had excellent teachers like Seshu Iyer, who was very famous. So you got an opportunity for a good higher education in Kumbakonam. I mean, of course, other than Madras. We have reached Ramanujan's house.
You know, this is where he must have sat down and worked through car synopsis and Loney's trigonometry.
Yes, and just imagine, this is where he worked on his big slate before he recorded his findings in those famous notebooks.
Right, he used to write on the slate and then flip over, write again, erase and then write.
That was here.
That was here.
And what we call as the first notebook got written here. I mean, a large part of it is written here, including that things on magic squares and things of that kind.
And you know, because of him, car synopsis and even more so maybe Loney's trigonometry is so famous. Even when I was a college student, we used to study Loney's trigonometry 70 or 80 years after Ramanujan.
Yeah, perhaps without him, nobody would even remember cars.
Yeah.
Car synopsis today. I mean,
Shirarchana kavari visum sajanir tirukudande
From time immemorial, the pursuit of divine found reflection in all creative endeavors. Ramanujan's mother was proficient in reciting verses from the Divya Prabandha. Little Ramanujan grew up immersed in the traditional milieu surrounding him. Folk games and mathematical puzzles reflect the culture of those bygone days. He was a gifted one, marked by the civilizational ethos of that time. His forays into the labyrinths of numbers were a way to experience beauty, the grace of divinity.
yeah, this is a new town high school which was formed in 1881. And Ramanujan joined here in 1898 in what was called as the first form, which is 6th standard in those days. The school discovered Ramanujan's intelligence, and Ramanujan discovered his mathematics in the school.
And look at the layers of history in this place.
You know, this place reminds me so much of my childhood.
Is that right? Your
Yeah.
school was like this?
Almost. I mean, I think there's some similarity amongst all these government high schools. The classrooms, the benches, the desks. On the board, you know, maybe there'll be a class monitor who's written attendance, how many were present.
Yeah. Well, this is where it all started for Ramanujan.
This is where it all started. Oh, look at these little fellows. Future Ramanujans, huh?
So are there any famous stories about Ramanujan as a young mathematician?
Yeah, I mean, in fact, one of the stories where he was discovered was, you know, the 0 by 0 story?
The zero? No.
Yeah, so his teacher was asking, well, he posed this problem to the classroom. If 1,000 bananas are distributed amongst 1,000 students, then each would get 1 banana. And then little fellow Ramanujan put his hand up and said, sir, if no bananas are distributed amongst no students, would everyone get 1?
Oh, amazing. So I guess maybe we already see at a young age he understood the importance of understanding variables and maybe producing something from seemingly nothing.
Yeah,
It's amazing.
early glimmers of his genius were already visible here.
Ah, yes, I agree. Take a picture. Okay.
Ramanujan was a student here in Kumbakonam in this government college. He should have been studying all these other subjects, but he didn't.
Right.
What did he do? He sat down and he just focused on mathematics, and he worked through card synopsis.
Ah, the crazy book with over 6,000 theorems and formulas.
Yeah, you know what? I've heard somewhere there's not 6,000. So the numbering is not linear. It goes, at every chapter there's a jump in numbering.
Uh-huh.
It's some 4,800, whatever it is, doesn't matter. But that was his mathematical training.
Wow. But surely, card synopsis was written in such a unique way that Ramanujan presumably emulated the format, right, when he recorded his findings in his own personal notebooks.
Right.
Yeah. Do you have a favorite?
My favorite, well, you know, there must have been a whole lot of series. Yes, he rediscovered Euler. The special values of the Riemann zeta function, and he rediscovered Leibniz or Madhva, 1 minus 1/3 plus 1/5 ... is pi by 4.
Yes.
He must have done all of that when he was a student here.
Yeah, that's amazing.
It's absolutely amazing.
Well, here's the beautiful river.
It really feels nostalgic to be here after 25 long years. The enigma of Srinivasa Ramanujan, and now the genius of Srinivasa Ramanujan.
In the very formative years, he traversed the mathematical canvas peopled with distinguished luminaries. His total absorption with numbers took him away from the prescribed curriculum and rendered him unfit for college education. Ramanujan blossomed outside the university system. He was already in his own realm, discovering theorems that paved way to recognition.
The work that he did after he returned to India is, although much more mature and more difficult, pertains to his earlier work and not so much to his work in England. I think that Ramanujan was creating a lot of new mathematics, and this creation of mathematics really lifted his spirit rather than cast him down. And he knew his collaborations with Hardy would be long remembered. These were absolutely great papers. But after he returned, then he went back to Q-series, and there are just an enormous number of beautiful results on Q-series in the Lost Notebook. And so this is a continuation of his work and a much deeper study of his earlier work on Q-series. So Q-series, partitions, Mach theta functions, those sort of are the main three topics in the Lost Notebook.
Modern developments in European mathematics passed him by, even in the big city of Madras Presidency. In his solitary pursuit, he was far beyond the comprehension of local intellectuals. Later in Cambridge too, his conjectures transcended the understanding of more than a generation of professional mathematicians.
Ramanujan had no interest in any subject other than mathematics. The best teachers could not attract his attention. But still, his concentration was always in mathematics. Mathematics, mathematics, mathematics. That's what it was.
Well, Ramanujan stayed in the Victoria hostel when he came to Madras.
Yes.
And it seemed to have a treasure trove of all kinds of books.
Indeed.
Related to his...
all other subjects.
Yeah.
Few in mathematics.
Right, but history, physiology, civics, biology,
literature.
Literature. Oh gosh, terrific. Only if he had spent a little more time reading all these books.
But remember, his interest was always in mathematics. Whatever other people might say or do, he could not be distracted from mathematics. It was mathematics.
He failed twice.
That was probably the reason why he failed in the other subjects.
Yeah.
He was doing higher mathematics, creative mathematics. That is what he was good at.
Representing a persona is an exercise in futility, and yet is attempted again and again. Sometimes it may open a window into the interior of the being. Sometimes it may not. There are no true images, only constructed ones. Enacting Ramanujan is far from being him. It is an act of speculation, to envision his presence, to lay bare the depth of his enigma. His gestures of erasure constitute folklore. They continue to occupy a place in our collective memory. He is alive, looking into our eyes, questioning our modes of understanding.
So these are these famous notebooks of Ramanujan.
The very original notebooks. That's incredible.
Somehow, you know, I didn't know this until I got started on this project, this movie project, that these famous notebooks are housed here at the University of Madras Library.
I can't believe I'm holding them. There are thousands of formulas in these notebooks. And look at the handwriting. It's impeccable, perfectly preserved. And because, I mean, the pages are weathered, but you can see we're holding history.
We are holding history.
So here you can even see some of his very first works on the magic squares.
Magic squares. And he has, in our modern language, this is a special value of the Riemann zeta function. It has zeta 2n equals pi to the 2n, Bernoulli b2n, factorial powers of 2. This is Euler. He has rediscovered Euler. And at some point of time, he realized that this was too precious and he wanted a copy, you know. So he rewrote Notebook 1, but he just didn't copy it down. He rethought, and this is like a revised and enlarged version of Notebook 1.
Still here in the second notebook, look at this page. This page is a sea of beautiful numbers. Formula 38 III, you find the continued fraction expansion for the Ramanujan function, nestled among so many other seemingly unrelated formulas. So here he is computing some of these class invariants. In fact, with no indication of how he computed these numbers at all, they're just listed as if this was a tax code table. Yeah. Right, here I have the third notebook. This is the last of the notebook. It turns out that most of the pages are blank. But what I do really enjoy about this notebook is how it ends. The very last page of this notebook contains nothing but gems. And here on the very last page, he begins with approximations to pi. Here's an approximation to pi that's accurate to 15 decimals. This one has 18 decimals. And then he ends the page with e raised to the pi times the square root of 58. This is a gigantic number.
How would one compute e to the pi times square root 58? He had no calculators, no computers. He did it by hand.
Yeah, I don't, you know, that's Ramanujan for you. He's an enigma.
He's an enigma.
I don't know how to answer that question.
You know, all these universities were not formed for doing research or undertaking higher education with a research orientation in India, but they were formed for essentially certificating and examining bodies. So the nationalist Indians knew that science and technology is very essential for a country like India, thought that they should create a space for doing research. So they had to form associations outside the framework of colonial universities. It's in a similar fashion that in 1907, some of the people got together and formed what is called as the Indian Mathematical Society. This society played a very important role in shaping Ramanujan. You know, it's only after coming to Chennai, Ramanujan got introduced to these people and this society, and also Indian Journal of Mathematics. So now Ramanujan could publish in that journal, so that a larger mathematician can look at it and give comments. He can also be part of the mathematical community. Secondly, this society also gave him a scope to learn new things, to get access to new materials, new areas of maths, which I think is a very important part in Ramanujan's life.
Hey, Dalawat, take a look at this. This is Ramanujan's very first published paper.
Oh, this is on some properties of Bernoulli's numbers.
Right, and this original journal is just falling apart. The papers are, I don't even want to touch it. It's so brittle.
Done so many calculations. He's calculated the numerator, the denominator.
You know what to me is the best thing about this paper? The fact that it is about Bernoulli numbers. Bernoulli numbers went back 2 centuries before Ramanujan.
Right, and they're still relevant today.
They're still relevant today.
Yeah.
Hey, isn't this some famous theorem? Primes dividing the denominator of Bernoulli numbers?
Ah yes, this is von Staudt-Clausen.
Right, von Staudt-Clausen.
Proved in 1840, I believe. I think Hardy said something about this. He says that Ramanujan rediscovered the famous theorem of von Staudt at a time of his life when he had hardly formed any definite concept of proof.
So this means Ramanujan just sat down, calculated a whole lot of Bernoulli numbers, saw the prime factorizations, and then he just saw the theorem.
That's exactly what it looks like.
Total mystery. I don't know how he did it.
Divergence series. எவ்வளவோ ஃபார்முலா, இத்தனை ஈக்குவேஷன். உண்மையிலேயே நீ ஒரு பெரிய மேது.
அதுக்கு நான் கட்டின விலை தான் இது.
அப்போ நாமகிரி தாயாரோட அருள்?
அது நான் கணக்கு தெரியாத வாட்டில சொல்றது.
ஏய், மூலத்தை அணைக்க இந்த தண்ணி தேவைதான். யார் ஜலம்?
இதுவே கங்கா ஸ்நானம் மாதிரி இருக்கு.
So Srinivasa, you have written some paper on Gauss, Ramanujan and hypergeometric series. Can you tell me something about it?
Yeah, what you have shown is the most general result, which is known as the 7f6 summation theorem. And on this page, entry 8 is what is known as the Gauss summation theorem.
Oh, okay.
What is beautiful about this chapter is that he starts with the most general result. And this is the most general summation theorem which is known in literature today. There is entry number 8 here, which you can see, is the Gauss summation theorem. And the beauty of it is that this is the one which he had seen in Carr's synopsis as an entry. This Gauss summation theorem. So the moment he saw that, it should have come to him as a flash that this is the most general result. How? You cannot answer. That is why you can call him as an enigma, he's a swayambhu, or whatever word you like, which is extraordinary. You can say that everything which came to him came from within. God said and Ramanujan wrote down. And that's why I was fascinated to write this article on Gauss, Ramanujan and hypergeometric series. Whatever Gauss and others had discovered from 1812 till Ramanujan's time, Ramanujan was able to reconstruct all that was discovered in Europe single-handed with only the hint of Gauss summation theorem in Carr's synopsis. Isn't it remarkable?
It's amazing.
You spoke about something following beautifully. What does beautiful in mathematics mean?
If you see how is it created, it's not necessarily by a rational approach or a logical or systematic approach. You know, any one of us who's tried a problem knows that often you go off in the wrong direction first, then you cross it out and you come back and you try many things until finally you see the right combination, right arrangement of things that the logic just flows beautifully and brings the conclusion that you want. And when you catch that, that's an aesthetic experience. You say, aha, kind of experience, and you feel it. And the deepest mathematics is such that when others read what you wrote, they can recreate that feeling of pleasure, that feeling, that aesthetic experience can be recreated, and so they can appreciate it. It's a lot like music.
I think the nature of the human mind in trying to manipulate mathematical ideas is somewhat similar to the nature of the musician trying to compose a symphony or a new concerto or a new composition, in that both the rules of music have to be followed and the aesthetic and harmonious component has to be kind of followed. And the same applies in mathematics too. And I think we're driven by that kind of aesthetic dimension of mathematics.
Sir, Orders of Infinityங்கிற புக்கில் ஹார்டி வந்து P of nக்கு எக்ஸாக்ட் ஃபார்முலா இல்லைன்னு சொல்லியிருக்காரு இல்லையா? ஆமாம். என்கிட்ட அதோட எக்ஸாக்ட் ஃபார்முலா இருக்குது. கொஞ்சம் பாருங்களேன்.
Oh, you mean the number of primes below a given number n, P of n? That's excellent. I don't think you can do any better than that. You have many more formulae in this notebook, and you have 2 notebooks. So you remember I was asking you to write to Professor Hardy. Hardy is a very reputed mathematician. He is well known in Europe. And to write a letter to him in which you mention about the formulae.
I beg to introduce myself as a clerk in the Madras Port Trust. I am now of about 25 years of age and striking out a new path for myself. I have made a special investigation into divergent series, the results of which are termed by local mathematicians as startling, but they are not able to understand me in my higher flights. If you are convinced that there is anything of value, I would like to have my theorems published. To Professor G.H. Hardy, Trinity College, Cambridge.
Some of the formulas in these notebooks is what went into his first famous letter to Hardy.
I see, yes.
And there is, so Hardy had a hard time deciding, whether this is genius or crank. And then there was a wonderful way for him made the decision. He said, this has to be a genius because if not, no one would have the imagination to, come up with these kind of formulas. And then Ramanujan comes here and he gets, in a few years, a degree from Cambridge, one of the top universities. Give us a sense of how Hardy and Ramanujan worked on a day-to-day basis.
I'm just guessing, but I suspect that Ramanujan would sort of tell Hardy his remarkable calculations or formulae, and that Hardy, being a very professional and someone who knew the subject very well, would probably then go away and try and prove them, you see. And then when he couldn't do it, he'd go back to Ramanujan, or he might realize Ramanujan had made a slight mistake or something like that. I suspect it was more in these terms. I'm sure that Ramanujan did a lot to inspire Hardy in many ways, and no, it is a remarkable relationship. I can't think of any other example. Of course, in terms of collaboration, I'm sure that Ramanujan was somehow a very exceptional collaboration for him, both mathematically and personally. Really, as the darkness of all that was happening in the First World War descended on England and Cambridge, I mean, everyone knew there were these terrible casualties and former Cambridge students were being killed with everyone else, that I suspect in this gloomy atmosphere, it probably was a ray of light of Hardy to have suddenly something new and inspiring and so on. I suspect that's
something very true and very positive.
Exactly. No, I think this is probably an important factor, yeah.
So tell me, do you have a favorite Ramanujan work?
Yes, of course. I love this body of mathematics that has come out of his one paper. It's called On Arithmetical Functions.
One of my favorites too.
Yeah. This is where he studies the Ramanujan delta function, which is built up in terms of the Ramanujan tau function. And this delta function is the first prototypical example of modular forms, which leads to automorphic forms, and there's a huge body of mathematics. If you want to understand that, you got to understand the delta function. You know, Ramanujan did lots of calculations with this tau function, and then he conjectured that, based on his calculations, that tau is multiplicative, which led to Hecker operators and Hecker theory. He made this guess about what is the size of tau of n, and this sort of had later avatars. There was this Way conjectures in arithmetic geometry, which Deligne proved in the 70s, and Deligne got a Fields Medal for this. It's mind-boggling to see all these areas of mathematics which are opened out from this particular paper of Ramanujan.
So it's incredible. This paper contains the delta function, which is the prototype for so many theories.
Right.
And I guess in this way, Ramanujan anticipated what would become the evolution of modern math.
Right, right. It's like there's this gigantic iceberg, and there's this tip of the iceberg, and on top of this tip is the delta function. You just got to understand the delta function, and then, you know, and to understand the rest of it.
And this all comes out of a paper innocently called On Certain Arithmetic Functions.
The multitudes of images relocate the memory of Srinivasa Ramanujan into our consciousness. Icons fashioned in the hope of deferring his absence for all time to come. His presence stands still in remembrance, inspiring in our gaze.
The passport photo, which was the best photograph that we had of Ramanujan. Paul Granlund, who was the sculptor in residence, agreed to do a bust, and it was awe-inspiring. We were very, very pleased with what it was. Copy was sent to Mrs. Ramanujan. We met her in 1987 at the centenary, and when we visited her home, she said when the bust arrived, it was as if his spirit had returned, and she garlanded every day. And that felt so nice, because this was something that she could appreciate directly from the mathematical community.
Tell me about that.
You know, that's a map of the sky when Ramanujan was born.
It's his horoscope.
So people use this to predict that person's future. Ramanujan's mother, Komalattamal, apparently knew his horoscope very well. I believe somewhere in Triplicane, in one of the houses that he lived there. Oh, this is the Janaki Amma. Certificate of candidate.
Oh, fellow of Trinity College. So I think he was elected shortly after he was elected FRS.
Right.
Quite a place, quite a collection. I know what this is. This must be 2 pages from one of the unpublished manuscripts of Ramanujan on the partition and the tau functions. For the modulus 11, here's the weight 10 Eisenstein series. This was his notation, Q times R. There's so much on this on these 2 pages. This is typical of the kind of calculations that Ramanujan did to arrive at congruences for coefficients of modular forms. Look at just algebra. Look at those equations. And so, presumably, if we're to turn the page, or a few pages later, he'll use this formula. As it's a very nice page.
I'm impressed with all these original letters.
Wow, look at this. You know what this is? This is one of the first letters that Hardy wrote to Ramanujan, 1913. Dear Mr. Ramanujan, this is real. Wow, and so here he is talking about Ramanujan's discussion on the distribution of primes in his letter. And it's actually very elliptic functions. Oh, look at this. And your results concerning the continued fractions of the type. That's great, the Rogers-Ramanujan continued fraction. This is precious. I've only read this in books. This is the original. It's amazing. It's great they have this museum.
So I discovered the Lost Notebook in May of 1976. And it was a complete surprise to me because my original reason for going to Europe was to attend a conference in France. And it was necessary for me to spend 3 weeks in Europe rather than just one because of the way the pricing of airline tickets worked. So I wanted to have some appropriate academic activities besides going to the conference. So when I went to the Trinity College Library and asked to see these papers, they came out in a couple of boxes. And in these boxes, besides the work of Watson, there were several things that were in Ramanujan's handwriting. One was the last letter that he'd actually written to G.H. Hardy in the last year of his life in 1920. And the other was a manuscript of about 100 sheets of paper, some written on both sides. Fortunately for me, I knew what the Mach theta functions were because I had written my PhD thesis on what Ramanujan described in the letter that he wrote just before he died. And looking through this document, I saw here are the Mach theta functions. So this must be the work from the last year of his life.
Wow, this is Ramanujan's bedroom.
This is the famous window where he used to sit for hours.
And the porch, right here. And you look out onto Sarangapani Street. Temples at the end of the block. This is a very famous place.
He used to sit here and work. Right here, at this window.
I'm speechless. I don't know what to say.
India has produced many talented mathematicians in recent years, a number of whom have come to Cambridge and attained high academical distinction. They will be the first to recognize that Mr. Ramanujan's work is of a different category. He has justified abundantly all the hopes that were based upon his work in India and shown that he possesses powers as remarkable in their way as those of any living mathematician. G.H. Hardy, June 1916.
The rudimentary ideas of the circle method were probably known to Ramanujan even before he left for England. After arriving in England, Hardy and Ramanujan applied the method to this particular problem of the partition function. The circle method is like a raga. It's the underlying technique or underlying tool in new discoveries in mathematics, and how you apply the circle method and how you improvise with it using the technique of the method is a kind of a determinant of the genius of the individual.
There are many problems in number theory where one is interested in knowing whether every integer can be written as a sum of integers of a special type. Important examples being Goldwa's conjectures and Waring's problem. And it was a method which was developed by Hardy and Ramanujan called circle method. Is a method which is normally used to solve such problems. And one can even see the genesis of the method in the very first letter of Ramanujan to Hardy, even before he met Hardy. And this is the method one which has enabled to get partial results on Goldwa's conjecture and a complete solution of Waring's problem.
And today what you saw is the procession of Narasimha. There are occasions when Ramanujan used to say that when he was being asked, how did you get this result, how did you get the result and so on, he will just say, I got it in a dream. And any amount of his explanation is not going to help. So he would have just fooled them by saying that he got it in a dream with Lord Narasimha dictating the equation to him. And he would see that result in an equation and he wrote it down in his notebook.
So, Ken, did you get it?
You know, beauty is very important in mathematics.
Oh, absolutely.
Didn't Hardy say somewhere that beauty is the first test and that there's no permanent place in this world for ugly mathematics?
Oh, absolutely.
I love that quote.
You know, theoretical math certainly goes back to the great Greeks, people like Pythagoras,
Beauty
Euclid.
was important to the Greeks.
It was very important to them. And as you know, they invented solid geometry, plane geometry, and they built beautiful buildings.
Now,
And
is there something about Ramanujan's mathematics connecting up to the Greeks?
oh,
and
absolutely.
beauty?
Actually, we can just talk about the golden number, the golden ratio. What could be
golden
more
ratio.
beautiful than the golden ratio? Let
Of
me
course,
show
of
you.
course.
So the golden ratio is a simple looking number. It's 1 plus the square root of 5 divided by 2. And lots of famous architectural structures and lots of pieces of artwork that are considered to be beautiful have been related to the properties of this single number.
Do you think this rectangle, this length by breadth, is the golden ratio? Maybe not.
Maybe not.
Maybe.
But it's a beautiful board anyway.
It's a beautiful board.
So what's very beautiful mathematically in terms of a formula about the golden ratio is it can be expressed as a fraction, what we call a continued fraction. A continued fraction is a fraction that descends forever, if you can imagine that being the case.
But this is very cumbersome.
It's very cumbersome, but it's still quite beautiful. This is a fraction that involves nothing but the number ones, and if it went on forever, you would find that this becomes very, very close to, and as a limit, equals the number 1 plus root 5 over 2.
Isn't there some other short form notation of this? You write 1 plus 1 and something like maybe stick in that 1 here.
Yes. I prefer this because it's easier for me to personally view it as a fraction, but absolutely, that would be the notation that Ramanujan used. What's amazing is that Ramanujan is quite well known for his continued fraction.
He was an absolute master.
Yeah, some people say that maybe as much as 20% of his notebooks involve formulas involving continued fractions. So what I like about Ramanujan is that he would start with, and I think this is what he did, he would start with the golden ratio, which has this beautiful continued fraction, and try to understand a function, say in a variable q, where everywhere the number 1 is replaced by q. Something like q to the 1/5 divided by 1 plus, and now here where all the q's come into play.
Oh, okay.
What Ramanujan did is he actually developed a theory of what we call class invariance, which, if you'd like...
That sounds deep.
It's very deep. This is stuff of the latter part of the 20th century in mathematics. You could think of the Rogers-Ramanujan continued fraction as being like a factory that produces beautiful numbers, these so-called algebraic numbers, of which the first happens to be the golden ratio. And what could be more beautiful than building a beautiful theory from stuff of the ancient Greeks?
This is amazing. And all that is linked to Ramanujan and continued fractions and starts here.
Ramanujan came up with a lot of astounding results in number theory. Do you think religion had some role to play in this?
We often hear of stories, but I think probably religion in the commonplace understanding played no role. I think that Ramanujan had tremendous faith in himself, faith in his inability, in his abilities to make discoveries, and I think he just pushed his inquiry passion into as far as it could reach. And so in that sense, he trained himself. And when you train yourself systematically, and then you can rise above the training, rise above the formal system of education, then you enter into the realm of inspiration and new creativity. There was no limit to his uncovering vast secrets. Even on his deathbed, for example, he was discovering the new theory of Mach theta functions, which I think you may have heard of. And that is, again, he found somehow, in his illness, he found refuge in the world of mathematical thought. And I think from that sense, that is true religion.
So here we are, underneath this beautiful temple.
That's Narasimha, yep. I find this rock, it's
amazing. It's overwhelming. It's beautiful.
It is.
Namakkal. You know, this is the Kal of Namakkal. You know what? Kal literally means stone. This is the abode of goddess Namagiri, the consort of Narasimha.
He's an incarnation of Vishnu, the protector.
கடவுளை ராமானுஜம் இன்னைக்கு அவரு ஒரு சயின்டிஸ்டாக கடல் மேதையாக திகழ்வதற்கு நம்ம நாமீர் தாயார் தான் முக்கிய பிரதான காரணம். அது வரைக்கும் நாமீர் தாயார் வந்து உத்தரவு வாங்கிட்டு அந்த உத்தரவு கிடைத்த பிறகுதான் சயின்டிஸ்ட் ராமானுஜம் நம்ம நாட்டுக்கு வெளிநாட்டுக்கு போய் நம்ம நாட்டுக்கு தாயாருக்கு முக்கியமான ஒரு பெருமையை சேர்த்து கொடுத்தவர் நாமீர் தாயார்.
Sometimes I feel it was his way to explain this kind of divine intuition.
Right.
Do you have any good example of his Ramanujan's intuition?
Oh, do I? I spent so many years thinking about the problem of Euler's partition numbers.
Oh, okay.
These are very simple numbers, and how many ways can you add up numbers to get numbers like, say, 4? Turns out there's 5 ways.
Okay.
But amazingly, for 10, turns out there's 42 ways, and by 20 there's 627, and by 50 there's over 200,000 of these numbers.
Over 200,000, yeah.
Ramanujan had this incredible intuition that allowed him to basically figure out the size of these numbers. And on top of that, as a number theorist, we're interested in their divisibility properties, and he's the first that shed light on how to think about the divisibility properties of these numbers.
You know, when Ramanujan was invited to Cambridge by Hardy, he didn't want to go because he felt that he would lose his caste crossing the seas. And so he came to Namakkal here and stayed in this mandapa with Narayan Iyer for 3 nights. And it's in the second night, I think, he got a dream. And the goddess appeared in his dream and gave him an indication that he is blessed, that he can leave for. And he woke up Narayan Iyer immediately and told him, I think the Namakkal goddess has given me her permission. That's the sequence that we want you to do this, you know, being here in this. Yeah? Okay, come.
Well, what's striking for me is here we are at the famous Namagiri temple where the story of Ramanujan, at least for the Western world, it started here. Without the dream sequence here, there would have been no Ramanujan for all of us. And that leads me to feel that I have to stress that Ramanujan is still very relevant today. It's a great legacy. Of course, it's a great story that we've told. The legacy is amazing. The legacy to theoretical math is unquestionable. But what's important is that Ramanujan is important to us in many invisible ways. He gave birth to, you know, parts of number theory which are used in cryptography, the construction of, you know, networks. A lot of graph theory depends on his ideas. And so Ramanujan graphs, and, you know, like I said, he is relevant today, not just to theoretical physics and math, but he's relevant to all of us, but in beautiful and invisible ways.
April 26, about 10 a.m. in the morning, Ramanujan passed away. It was a very sad moment, and it was even sadder because there were hardly anybody for his cremation. And the Purohits who were supposed to come to perform the last rites had refused to come, and the family was in a great dilemma. The last rites has to be performed before the sundown, and there was no Purohits. Why? Because the Purohit said that he has crossed the seas and hence he is no longer a Brahmin and we won't perform his last rites. Few Purohits finally agreed to come after a lot of persuasion, and finally the cremation was held. It was same Ramanujan who 1 year ago, in 1919, when he came back to India, the people had gathered to felicitate him. The people were willing to rub shoulders with him, but during his last ride, there was hardly anybody.
Gometra Bungalow has been demolished at the altar of commercial development, some years after this earlier film was shot here. Ramanujan's passion for the beauty of numbers was so intense that he endured pain while working on his last offering, the Mach theta functions. He was only 32 years old when he died. The sequence of pillars evoke the symbolic form of Lord Narasimha.
A great Russian mathematician Shafrovich once observed that a superficial glance at mathematics may seem to give an impression that it's a result of separate individual efforts scattered across continents and ages. However, the inner logic of its development brings to mind a work of singular intellect, developing its thoughts systematically and consistently, using a variety of individual efforts only as a means. It resembles an orchestra performing a symphony conceived by a single person. This is no doubt true, and yet the music reaches a crescendo in the hands of only a few luminaries. One such luminary was undoubtedly Srinivasa Ramanujan. In this cosmic symphony of mathematics, he played a major role.
I'm extremely sorry for not writing you a single letter up to now. I've discovered very interesting functions recently which I call Mach theta functions. Unlike the false theta functions partially studied by Rogers, they enter into mathematics as beautifully as the ordinary theta functions. The functions in this letter are pieces of what we call harmonic mass forms. That realization, combined with the dozens of papers that people had written on the Mach theta functions over the last 80 years, led to a real explosion of mathematics. The letter begins with a discussion of asymptotics near roots of unity for what he refers to as Eulerian theta functions. We call these modular forms, special kinds of modular forms.
Did he use this phrase, modular forms?
No. When he uses the word ordinary theta function, that's what he means. He means modular form. So the one question that he raises is this: can there be an Eulerian series that somehow pretends to be a modular form, but isn't a modular form, and hence the word Mach? Math took many steps forward because of his letter, even without understanding what he wrote in this letter. Now I think finally in 2012 we have that understanding, and the picture is, it's incredible, it's breathtaking. Yeah.
Anam